Algebraically, what do we have to do? Or what are we looking for continuity?
Just don't step on it to push it down.
No.
If it's a big.
The bottom blown up, right? So you're probably going to have to factor the thing. Now, in the name of the game, what's going on? One of these is probably a probably. It doesn't have to be, but it probably is if you try it. So I got to have a -2. Does that work? Yes. So is this continuous? It's not continuous at 2 and -6.
Now, how did you determine that?
-6 blows it up. 2 blows it up.
But the -6 is removable, right?
And yep. And now I could actually.
Oh, okay, I got you.
And there's the removable.
Wait,
Yep,
you opened dot -6 because it cancels
I
out,
removed it from the original problem.
So,
So,
give you another one. Removable.
If you want to do another continuous thing, it's right here with the piecewise, with the limit. There's 2 questions here. A limit question and a continuity question, if you want to do those right while you're thinking of it. Take a peek. Don't freak out on the brackets, because what's really the only thing you ever do?
plug them in.
Take these 2 numbers and plug them in. No matter if I'm asking you what's the limit or whether it's continuous. You're going to take the chunk numbers and plug them in. And then you see what happens. Alright? So these are my 2 numbers. The first question is, what's the limit as x approaches 3? Coming in from the left, it goes to 5/3. Coming in from the right, it goes to 6/3. Do not touch, so does not exist.
And it is not
And now the second question is it continuous? These are not the same, so it's not continuous. Now here's where people screw up. Not continuous at x equals 3.
What if those are different numbers?
Because these numbers are different.
But if they're the
No,
same,
like-
what?
If they're the same, then it's continuous.
Those numbers are the y values, right?
That's the y values. You want the x values. Yeah. This is where the x value is, where it breaks up. If you were to draw it, you'd see this.
Yeah, I get that.
But in the
But see,
piecewise,
that's too simple. There, you just looked at they're both 3, so x equals 3. But what if the?
You're not going to have a 2 and a 4.
Okay.
They're going to always be the same. That's why it is that simple. I hate to say that, but that's what it is. Yeah.
we got that.
Before you go, I'll keep running the tape and I'll finish these out. But this is what kind? Rationalization? What's this?
You factor in.
It might factor, but look at it. This is all positive up here.
Yeah.
It's not going to factor, so this is a infinite limit one.
So then what?
So you go to the.
So since we're here, I guess we might as well. This is infinity. Pick 0.9.
Oh, right.
Be a negative on the
That's a
bottom.
positive on the top and a negative on the bottom. Negative infinity.
Are you going to talk through the other one?
Yeah, I'll try.
We do have detention at this time in the high school
I
office.
don't have a long time.
Shoot, we have served tonight in the high school office right now. Right now.
What if
Why would you?
Can you multiply top and bottom by that?
Mr. Galvin, please call high school
Okay.
office, Ms. Galvin.
No,
I think it's funny.
no.
Make sure you don't multiply the bottom out.
Why do
Leave it, it'll work out a lot better. But the top,
I know I don't want to mention.
What would you got an detention for?
Stop reading Kleenex.
Would Tyler Smith and Dylan Sherman please come to the athletic office? Tyler Smith and Dylan Sherman, please come to the athletic office.
Erica, when do we have to determine the positive and negative? Is that only,
when it blows up and you got nothing else to do.
so we had,
Would Courtney
Let
Hoffman
me finish
please
this
report
one.
to the guidance office? Courtney Hoffman.
And the 2's go away,
X becomes a 1.
X goes away, and I'm left with a 1 on the top. And my problem child's
A
gone, so now I
reminder to
can,
students who do not,
Okay.
who have to wait for the bus, you need to wait in the large commons here at the high school. No students are allowed at the middle school building or any other school building, including Kemper. Thank you.
I did that, so that's square 2 over 4.
How'd you get the 2 square root of 2?
1 square root of 2 plus 2 square root of 2. Because that's the square root of 2 plus 0.
Yeah.
So I got 1 square root of 2 plus another square root of 2 is 2 square root of 2.
so in our final answer,